Good morning, dear students. Today we are going to start a new chapter. The chapter name is Atom. So you all are familiar with this atom. So during your previous classes and all, during your high school classes, you have studied about these atoms. So you all know that the atom consists of a nucleus, central nucleus, and the electrons are revolving around the nucleus, that is electrons. And again you know that this nucleus is consist of the and protons and the neutrons. Protons and the neutrons. You know that the electrons are negatively charged, protons are positively charged, and the neutrons are neutral. So atom as a whole is electrically neutral. That is, charge on electron is nullified by the charge on the proton. Again you know that the structure of atom. So structure of atom consists of, this will be the nucleus and the electron is revolving around the nucleus, or you can see that the structure of atom as shown in this diagram. Okay, ನೀವು ಯಾವಾಗಾದರೂ ಯೋಚನೆ ಮಾಡಿದರೆ ಯಾಕೆ ಅಟಮ್ ಇದೇ ಥರ ಇರಬೇಕು? ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಎಟ್ ದಿ ಸೆಂಟರ್ ಇದೆ and the electrons are revolving around the nucleus. Why the structure of atom must be like this? In order to study this, you have to know the history of the atom. The history of the atom, it originates from the Greek. So in ancient Greek, there was a debate about the nature of the matter. So matter is nothing but anything which has mass and occupies space is called as matter. So there was one question. So questions, it is illustrated like this. If you have any material, let us consider this as a material of certain length. If you make it half, so cut it and make it half. So when it is half, take one half. Again this material, it is cut into half. Okay, again this piece, it is cut into half. So ಇದನ್ನು ನೀವು ಎಲ್ಲಿ ತನಕ ಕಂಟಿನ್ಯೂಷನ್ ಆಗಿ ಮಾಡ್ಬೋದು. So is it possible to continue this forever? So this was the questions. So in order to answer these questions, there were two philosophers, that is Greek philosopher. One is the Democritus. He said that it is possible until it reaches one point. That point is indivisible. That indivisible is called as atomos. He called that point as atomos. It is his views. Who said like this? Democritus said that we can do this until one point arises. At that point, that material cannot be divided further. That point he called it as atomos. Atomos, it is nothing but indivisible. So one more philosopher, his name is Aristotle. Aristotle said that you can keep on doing this. So you can, when you do this, cut this again, you will get one point, and that point is also the half of the previous one. That is nothing but when you reach the end, it will be the half of the previous end. So his Aristotle view was the little practical, so it is accepted till 2000 BC. So during this period, they were thinking that there is no material or the point, it is called as atoms. So in 1803, John Dalton, he said that matter composed of atoms which are indivisible, that is, they cannot be divided further, and all the atoms of the given elements are identical. So example, if you take the hydrogen atom, 1H1, 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 all are identical. So atoms of different elements have the different weights. That is, now we call it as the atomic mass or atomic weight. The mass of hydrogen is different from the mass of oxygen. So it indicates. So one more is said that atoms of atoms combines in simple ratio to form the compounds. So that is, you all familiar with the formation of water. So formation of water, it is called H2O. That is two hydrogen atoms and one oxygen atom. They will combine in simple ratio. Simple ratio means so only two hydrogen, one oxygen. They will form one molecule. That is called as compound. He concluded that atom is the building block of elements. So this was the views of who? It is John Dalton. So okay, but in 1896, J.J. Thompson, 1896, J.J. Thompson, he done one experiment. He did one experiment. His experiment includes one discharge tube. This is the discharge tube. Here it will be negatively charged and it will be positively charged. So this is battery, positive, negative, and here it is the positive and here it is negative. So and he filled this chamber with hydrogen gas. He filled this system with hydrogen gas. When the switch is plugged on, so then the current is passed through this tube. So he observed that, carefully observed that this gas, it will get so evaporated, excited. So then he applied electric field. So you all know that electric field, this is the positive, this will be the negative. As he observed that here the gases were moving like this. This is positive and this is negative. Careful observation indicates that some of the particles are moving towards this positive electrodes. So being this positive electrode, he concluded that this negative, some charges are here, some charges are present. These charges are nothing but they are negatively charged particles and they are attracted toward this positive electrodes. So he said that these negatively charged particles, he named it as an electrons. So he said that the atoms, it is not indivisible, it can be divisible. So it is divisible into some negatively charged particles and some positively charged particles are they moving to this electrode. So who did this experiment? J.J. Thompson. In 1896, J.J. Thompson did one experiment. He took one cathode ray tube or discharge tube. So it is connected to a battery. This is positive terminal, negative terminal. This is battery. So these are called as anode and cathode. And this chamber is filled with the hydrogen gas. When the current is switched on, this gas ionizes. And when he applied these fields, that is positive and negative, that is nothing but the electric field. Careful observation revealed that some particles are moving towards this positive terminal. You all know that the negative particles and positive particle, they will be attract each other. That is, unlike charges attract each other. So he named these particles as the negative particle. He named it as a electron. So that the atom, it is the mixture of positive charge and the negative charge. For this observation, from this observation, he gave one model. That model is called as J.J. Thompson's atomic model. J.J. Thompson's atomic model. According to this model, the positive charge of the atom is uniformly distributed throughout the volume of the atom like pudding. You can see here. And the negatively charged electrons are embedded in it like plums in the pudding. So these are called as pudding. This model, therefore, sometimes it is called as plum pudding model. Or one more example, you can consider it as a watermelon model. So that is, seeds of the watermelons, they will act as the electron and the remaining part, it will act as a positive charge. So this J.J. Thompson model was successful in explaining the stability of the nucleus. How it is explained? That is, the positive charge of this pudding, it is neutralized by the plums present in the pudding. That is, the atom is electrically stable. So, okay, thank you.